I've been a software developer for about 20 years, and for about the last decade, I've been doing software architecture, mostly solution designs. And I think that these five traps that interfere with new software architects' ability to come up with decent solutions are worth talking about. So the first pitfall that you're going to run into is the latest fashion. When I was coming up, service-oriented architecture was like the architecture that you needed to follow. It's very uncommon to see it now. DCOM was pervasive and remote procedure calls using that technology. And a few years ago, GraphQL was basically everywhere. There are problems with these technologies, and if you go all in on any of those, you're gonna find out that those problems exist. Sometimes fashion survive though, and I think that there are a group of technologies that are very mature now, and that you can rely on, and if you choose them, you have a high chance of your system still being stable and still using those technologies in a few years. And those three are SQL, REST, and some form of messaging protocol. And, I think that you can't go too far wrong with those. The next pitfall I've seen is modularity at all costs. And I think that, I think if you've got your ear to the rail, then you're starting to notice that there's a growing consensus that microservices have been overused by the industry, and there's sort of a pullback from that. And I think that, if you have microservices with a lot of dependencies between them, there's sort of an erosion of the benefits that you could get from microservices. In some cases, you don't actually have a lot of choice about, you need data from other parts of the application, but if you're building a system like that, are you sure it needs to be modular? And that's the question. A lot of the time, you can get away with a layered architecture and maybe taking some strategic parts of your architecture out and modularizing those for good strategic reasons, like you have wildly different operational requirements for a particular part of the application. It has to have very high uptime, for example, or needs to scale, or needs to be elastic and scale up and down at short notice, or needs to run on private hardware because you need to keep the data that it holds protected, for example. So these are good reasons to split your application into pieces, and the default of choosing microservices and modularity, well, that's becoming less popular. And I know that I talked about fashion, but actually there's a good reason for this, and that's because we think that as an industry, we think that we've overused this technology. Okay, the next pitfall is reuse and overuse of reuse. And I think that every software developer wants to write good reusable code, and refactoring feels really fun and good to do. But what feels not so fun is changing a piece of very heavily reused code and realizing that you have to test the fuck out of your entire software suite. And nobody wants to do that. So, there is a cost to reuse, and just remember that, it means that changing it is difficult. And there's a reason why Solid has O in it. That's the open close principle. If you want to build reusable software, you need your components to be open for extension, but not modification. That is the contract that you're signing up for. And remember that reuse means that you can't change your software later. Well, you can, and I know everybody does this, but remember that there is a cost to pay. And like the final thing that I'll say about reuse is many times people build their piece of software, be it a class or a method or an entire component for reuse, and then use it once. And like you've over-engineered this. There's no doubt about it. If you build something for reuse and you use it just on a single occasion, there's no point in you having done that. Adverse coupling is about when you group pieces of software together, and I think that, it's related to reuse in a way as well, and it's more about how when you change things, how you might inadvertently affect bits of software that you don't really want to affect. An example of that is if you have two sort of related classes together in a single component and you change one of those classes and you have a piece of software that relies on another class in that component, well, actually that other piece of software may actually need to be rebuilt now. And you don't know, you need to rebuild it and test it and see what has happened. Or, you need to do some analysis, some work to actually verify that you don't need to build the new thing again. So, there's some overhead involved in grouping those components together, and that causes coupling. There's a concept called stamp coupling, which is where if you rely on a contract that is more extensive than what you require, then changing that contract can inadvertently change the behavior of the software that uses that contract. An example of this is like changing the default on a property, or adding a new default property. Let me just run that through for you. If you've got a contract that has a default property, and you've got a client that will load the data from the back end and then store the data to the back end again, then that client will have an internal representation where it might chuck away fields that it doesn't know about, and then the default will be installed in that particular property when it calls the update message, and that's problematic. And that only happens because you're attempting to share a contract. So the alternative is to have individual contracts per client, and yes, I know this is duplication. So Eric Evans in his DDD book, he talks about the hexagonal architecture, and the point of this is that you have a common kernel that you can share, and then you have these APIs that are for a particular client which wrap that common core. So the next thing that I wanted to discuss is the overuse of messaging. I think that messaging is really good and it has its place. It's great for situations where there's something that you need to happen downstream of an action that a user performs. And it's good for things like notifications where you don't know that something's going to occur. And it allows for eventual consistency, which is it's a really good way of decoupling your applications from one another. And it's a pretty good goal to try and achieve. But in user-facing scenarios, messaging is prone to timeouts. And the reason for this is whenever you've got messaging, asynchronous messaging, then you will inevitably have a queue in place. And sometimes, that's good because it means that all of your messages get processed eventually. But if queues get saturated or overfull, then round trips will time out. And quite often there's no good way of performing a cancellation. The thing is in the queue, and there's no way to intervene or deal with that while it's in the queue. So you can't revoke the message. It's just, away until it gets executed at the other end. So I think that if you've got a user-facing scenario, you should just use an API and use REST, and that's a better scenario. So what do you think? Have you seen any other pitfalls? I'd love to hear about them. Share them in the comments. And if you like this, let me know.